Hello guys, welcome back to my channel mathschool. In this channel, I'll be teaching you Karnataka State Board Class 10th NCERT Math. In my last video, we started with the chapter number 8, Real Numbers. After a brief introduction, we learned about the topic Euclid's division algorithm and also solved the example problems on this topic. Now, in today's video, I'll be teaching you exercise 8.1. So guys, let's get started with the video. Now coming to the exercise 8.1 from your textbook, the first question says use Euclid's division algorithm to find the HCF of these three questions, that is 135 and 225, 196 and 38,220, 867 and 255. Okay, this is very easy guys. I've already solved this problem in the example. I'm leaving up to you to try these problems. And if you find any difficulty, please comment me in the comment section below. I'll solve these problems for you. Next question is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Again, this we have solved similar question in example number 4. You have to assume a as to be a positive odd integer. Then take b value as 6 and substitute this value in the Euclid's division algorithm, which says a is equal to bq plus r, and where r lies less than or equal to 0 and less than b. By substituting a and b value, you will get a equal to 6q plus r, and r can be either r can be less than or equal to 0 and less than 6. So r value will be 0, 1, 2, 3, 4, 5. Substitute this value in the equation you got after applying the Euclid's division algorithm. Then you get some values of a. In that values of a which you have obtained, you should determine the positive odd integers. If it is divisible by 2, it will be positive even integer. If it is not, then it is positive odd integer. And now let us solve the third question from the exercise 8.1. An army contingent of 16 members is to march behind an army band of 32 members in a parade. The two groups are to march in same number of columns. What is the maximum number of columns in which they can march? So first of all, let us understand the question. Here they say a 16 member of army contingent and 32 member of army band have to march in two groups and one behind the other. Okay, if these are two groups, 16 member of army contingent, they have to march ahead of army band of 32 member group. So we have to determine the maximum number of columns in which they can march. Maximum number of columns in which these two groups can march, one behind the other. Okay, to determine that, we have to find the highest common factor or the HCF of the two groups, 16 member group and 32 member group. Therefore, we have to apply Euclid's division algorithm. Apply Euclid's division algorithm to find the HCF of 616 and 32. Therefore, what does the algorithm say? A is equal to b into q plus r, where r will lie less than or equal to 0 and less than b. Now, since a should be greater than b, we will take a as 616 and b as 32. Now apply this a and b value in the algorithm. We get 616 is equal to 32 into q plus r. We have to divide 616 by 32 to find q and r. So let's divide 616 by 32. If you check in the table 32, if you take 19 times of 32, you get the result as 6 not 8. Okay, so after subtraction the result is 8. Okay, so here I'll show you 32 into 19. If you check, 9 2s are 18, 9 3s are 27, 28, then 2 1s are 2, 3 1s are 3, so 8, 10, carry 1, so 2 plus 1 3, 3 plus 3 is 6. Okay, this is how you get 32 19s are 6 not 8. So after so the remainder what we got is 8. So writing down in the equation 660 is equal to 32 into 19 times will give you the remainder 8. Now since the remainder is not equal to 0, we will reapply the Euclid's division algorithm to 32 and 8. So dividing 32 by 8, 8 4s are 32. So result is 0. So writing down here, we can say 32 is equal to 8 into 4 plus 0. So since the remainder is 0, we have to stop the division and the present divisor 8 is our HCF. Therefore, we can say the maximum number of columns in which both the groups can march is 8. Okay, in 8 columns both the groups can march one behind the other. So this is the answer. Now let us solve our fourth exercise problem 8.1. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. They have also given a hint in the question which says, let x be any positive integer, then it is of the form 3q, 3q plus 1 or 3q plus 2. Now square each of these and show that they can be rewritten in the form 3m or 3m plus 1. So since in the question they have given us the hint to assume that x be any positive integer, we will assume here let a be any positive integer, and b is equal to 3 according to the hint given. Okay, so let us use Euclid's division algorithm now, where a is equal to bq plus r and r lies between 0 and b. So applying these a and b value to the algorithm, we will get a is equal to 3q plus r, where r is less than or equal to 0 and less than 3. Since b is equal to 3, we get r lies between 0 and 3. So we will have 3 different values of r, such as 0, 1 and 2. Now let us apply each value of r to a and square on both the sides to get the result. So in the first case, let us assume r is equals to 0. Apply this in equation. Let us take this equation as 1. In equation 1, we get a is equal to 3q. Now square on both the sides. Squaring on both the sides, we get a square is equals to 3q the whole square, or a square is equals to 9q square, or we can write a square is equals to 3 into 3q square. Now let us assume let m is equals to 3q square. Therefore we get a square is equals to 3m. Okay, we got the first result. Now similarly, let us assume r is equal to 1. Now applying this to the equation 1, we get a is equals to 3q plus 1. Now squaring again on both the sides, we get a square is equals to 3q plus 1 the whole square. Therefore, we will have a square is equals to a square, a plus b the whole square formula we will apply. So a square is 9q square plus 2 into 3 6q into 1, so it is 6q plus 1. Now taking common here in these two terms, if we take 3 common, we will get 3q square plus 2q plus 1. So let us assume m is equal to 3q square plus 2q. Therefore, we will get a square is equal to 3m plus 1. So we got the second result. Okay. Now taking the third value of r, where r is equal to 2. So applying this again in equation 1, we get a is equal to 3q plus 2. Now square on both the sides, we get a square is equal to 3q plus 2 the whole square. Again using the a plus b the whole square formula, a square is equal to 3 3s are 9q square plus 3 into 2 is 6, 6 into 2 is 12q plus 2 2s are 4. Now again let us rearrange this term. Let us write 9q square plus 12q. So instead of 4 we will write 3 plus 1. Now taking 3 common factor in these three terms, you get 3q square plus 4q plus 1 and plus 1. Now let m is equal to 3q square plus 4q plus 1. Therefore, a square can be written as 3m plus 1. Okay, so we have proved now that any positive integer, since we had considered a as a positive integer, so any positive integer is of the form 3m or 3m plus 1. Okay, this is very easy, guys. If you just concentrate and understand the problem, you can solve this. Now let us solve our fifth question from exercise 8.1. This is the last question from the exercise, guys. So the question is, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Okay, so according to the question, here we have to cube any positive integer. In the previous question, we squared the integers. Here we are going to cube it. This is very much similar to the previous question which we solved. So here also let us assume let a be any positive integer. Let a be any positive integer. Okay, and b is equals to 3. Now apply Euclid's division algorithm. Which says a is equal to b into q plus r, where r lies less than or equal to 0 and less than b. So applying a and b value, we get a is equals to 3q plus r, where r lies less than or equal to 0 and less than 3. Therefore, we will get three different values for r, that is 0, 1 and 2. Now in the first case, let us use the value r is equal to 0 and apply in this equation 1. Okay, so r is equal to 0, apply in equation 1, we get a is equals to 3q. Now we have to cube on both the sides. We get a cube is equals to 3q the whole cube, which is nothing but a cube is equal to 27q cube Now we can write this again as 9 into 3q cube. So let m is equal to 3q cube. Therefore we can write result a cube as 9m. Okay. Similarly, let us apply r is equal to 1 in the equation 1. So let us apply r is equal to 1 in equation 1. Therefore we get a is equals to 3q plus 1. Again cube on both the sides. We will get a cube is equal to 3q plus 1 the whole cube. Now we have to expand using the formula a plus b the whole cube. So let me write the a plus b the whole cube formula, which is a cube plus b cube plus 3ab into a plus b. Using this formula we will expand here. So 3 cube is 27 q cube plus 3ab is 3 3s are 9. So 9 cube. A plus b is again 3 cube plus 1 and b cube will be 1. So opening the brackets we will get 27 q cube plus again 27 q square plus 9q plus 1. Now let us take 9 common here. So we get 3q cube plus again 3q square plus q plus 1. So let us take let m is equal to 3q cube plus 3q square plus q. The bracket will come here. This is not the bracket. Okay, so if we substitute m value, we will get 9m plus 1. Okay, so let us again substitute the third value of r, where r is equals to 2. Let us apply this in equation 1. We will get a is equals to 3q plus 2. Now again cube on both the sides. We will get a cube is equals to 3q plus 2 the whole cube. So applying a plus b the whole cube formula, let us go expand this. So we get 3q cube is 27q cube plus 3ab is 3 2s are 6, 6 3s are 18q into a plus b is 3q plus 2 plus b cube is 2 2s are 4, 4 2s are 8. Therefore again let us open the bracket. 27q cube plus 18q into 3q is 54q square plus 18 into 2 is 36q plus 8. So now let us take again 9 common. If you take 9 common, you get 3q cube plus 6q square, because 9 6 are 54, and 4q here because 9 4s are 36 plus 8. Okay, so let us assume let m is equal to this value 3q cube plus 6q square plus 4q. So substituting the m value in this equation, we will get a cube is equal to 9m plus 8. Hence we have proved or shown that by using Euclid's division lemma, the cube of any positive integer is of the form 9m, 9m plus 1 and 9m plus 8. With this, we complete the whole exercise of 8.1, guys. Hopefully you have understood all the example and the exercises problem. But still, if you have any doubt, you can please comment me down in the comments section. So this completes our topic Euclid's division algorithm in chapter real numbers. In my next video, I'll be taking up topic fundamental theorem of arithmetic. So guys, if you like my video, please like, share and subscribe to my channel Math School, and please don't forget to hit the bell button below to get latest updates of my videos.